Okay. Yes, children. Hello. Hello. Hello.
Hello, ma'am.
Yes, beta. Can you hear now?
Yes, ma'am.
Suddenly, I don't know, the meeting got ended. Okay. So let's continue. Okay, beta. So we were doing that if these two big angles are equal and the smaller ones are also equal, we just have to say that whether the remaining parts are also equal or not. Will that be equal?
Yes, ma'am.
Tell me, will that be equal?
Yes, ma'am.
And which axiom applies in that? Sorry, which axiom applies here?
Ma'am, will it be things which are half of the same things are equal to one another?
Say it loudly. Which axiom are you saying?
Ma'am, will it be things which are half of the same things are equal to one another?
Things which are half of the same things are equal to one another. That's absolutely right. So this also follows, and you can even say that if equals are subtracted from equals, is it? Yes. So
Yes,
there are
ma'am.
two ways to say that, no? So there are two ways to say that. Right, children? So you can write both ways. If it is asked in the exam and if whatever you feel like, if halves, things which are half of the same things are equal to one another. So that also you can write. So which axiom follows here? We'll just write down. Axiom follows are,
Ma'am, second or seventh one.
so we don't have to write the second or seventh, but we have to write the statements. Okay, beta? So you said things which are half, things which are halves of the same things. Things which are halves of the same things are equal to one another. Yes. So this was the axiom that followed, and it can be said in another way of also. What is that? If equals are subtracted from equals, the remainders are equal. If equals are subtracted from equals. So please, you have to write, whenever you are asked like this, no, you have to write the axiom that follows. Okay. So if equals are subtracted from equals, the remainders are equal. I hope you are understanding this, how it applies in the questions. Yes, children? Hello? Are you writing?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Please do make a note. Okay, so this chapter does not need any big calculations or something. It's just, you just have to identify which axiom or which postulate follows. Okay. So you can write here, if it is asked here angle PQR, so you can write here this from angle PQR if you are subtracting angle PQO, that will be equal to angle PRQ minus angle PRO. Okay, so these were equal and the equals have been subtracted, so the result is also equal. And axiom which follows is these two axioms. Okay, let's see another question here. The next question it says is state Euclid's fifth postulate. So can you state? Who will tell me? Rohit, tell me Euclid's fifth postulate.
Ma'am, one second. Ma'am, if a straight line following on two angles,
Yes.
Straight lines make the interiors on the same side of it. Make the interior angles on the same side of it.
Okay, if say it again.
Ma'am, if a straight line falling on two angles, make the interior angle of it on the same line of it.
See, when a straight line falls on two straight lines, it's that if a straight line falls on two straight lines, okay, so angles made on the interior side of it is the sum of the angles made on the interior side of it are less than 180 degrees, then we can say that the lines will intersect on the same side of the
Yes,
straight
ma'am.
line. Okay, so lines will intersect on the same side of the line and same side of the line. You can even name this same side of the line L if it is produced. Okay. Yes, children. And please write the statement. The writing of the statement is required in this. Suppose if you get this question, Euclid's fifth postulate. So you have to write the statement first and along with the figure. Okay. Then you will get your full marks.
Yes,
Your
ma'am.
statement and this figure. Okay. Okay, let's see another one. In the figure, now this is the figure I'm showing you here. A, C, B, and D. Okay. In the figure, AB is equal to CD. Those who have this, those who have Euclid's geometry in their books, please do the exercise sums today. Okay. Will you do that? Whatever book you have, whether it's NCERT or any other book. So please do the sums of that. Yes, children, will you do that?
Okay, ma'am.
Yes, ma'am.
Okay. So whatever book I have, I'm doing sums from that. Okay. So please, whatever book you have with you, whether it is NCERT or any other book, please do the examples and the exercise questions of the book. Okay. In the figure, AB is equal to CD. Okay, AB is equal to CD. Prove that AC is equal to BD. Okay. Also write the used Euclid's axiom. Also write the used Euclid's axiom. So whatever axiom is used here, that also you have to mention. Okay, this is the question. It's very well specified in the question. In this figure, AB is equal to CD. Prove that AC is equal to BD. Okay, and write the axiom. So what do you think about this question? See, if I have AB equals to CD, now to get AC out of this, that means from AB, if I want AC, that means I will have to subtract CB. Okay, I will subtract CB. Okay, I will subtract CB from here. And from this CD, if I want just BD, that means again I will have to subtract BC from here. Is it? Are you understanding?
Yes, ma'am.
Okay. So that means if I from AB, if I'm subtracting BC, that means that's equal to AC. And from CD, if I'm subtracting BC, I'm getting BD. Okay, so this is what I was asked to find out. We have done. Now what axiom follows here?
Ma'am, if holes are subtracted, no, ma'am. If the equals are subtracted from equals, the holes are equals.
Very nice. If equals are subtracted from equals, the remainders are equal. Okay, when you subtract something, you get the remainder, no? If equals are subtracted from equals, the remainders are equal. Okay, so please write the axiom that follows. So the maximum importance in this question is this part. So axiom that follows. So you will write here, when equals are subtracted, when equals are subtracted from equals, the remainders are equal. Okay. So this is how the questions are done in this. Okay, let's take some more. Okay, let's take this question. Question 1. If a point C, if a point C lies between if a point C lies between 2 points A and B, such that AC is equal to BC, then prove that AC is equal to half of AB. Explain by drawing the figure. Okay, this also you have to do. Explain by drawing the figure. Okay. Okay. Although it is not written that you have to tell the axiom, but it is mandatory that you should tell the axiom. Okay. In such questions, you should always state the axiom or the postulate which is followed. Okay. If a point C lies between 2 points A and B, okay, let's draw a line AB, A to B, and a point C lies between these 2 points. Then prove that AC is half of AB. Now we have to prove that AC is half of this AB line. How will we do that? Let's see. Given, we can write here, we are given that AC lies between C lies between 2 points A and B, such that AC is equal to CB. Okay, if AC is equal to CB, then that means
Ma'am, then ma'am, we can even write AC plus CB is equals to AB.
so that means if we take AC is equal to CB, this is already given to us. So we just have to prove it. So that means if we add AC to AC, AC में अगर हम AC add करेंगे, okay, and CB में भी अगर हम AC add करेंगे, okay. Are you understanding? If we add AC with AC, if we add AC with CB, I'm adding equals. Are you observing this? I'm adding equals to these were already equal, and I'm adding something equal to it. Okay, so that gives me 2AC, which is equal to CB plus AC is AB. And I can write this AC is equal to 2 comes down this side, this becomes 1 by 2 AB. Is it? Yes? Can we do that? Is that true?
Yes.
Yeah, ma'am.
So what can I write here? Which axiom follows here? Any axiom, any postulate, anything that follows?
Ma'am, things which are double of each other are equal to the same thing.
Things which are double.
Double of the same things are equal to one another.
So
Ma'am,
what was double here?
Ma'am,
Ma'am. Ma'am, it will be if equals are added to equals, the wholes are equals.
Yes, absolutely. Okay. So it's not that. Maybe if equals are added, see, I said these are already equal, and I have added something equal to it. So if equals are added, if equals are added to equals, the wholes are equal. So please write down that. So axiom that follows is if equals are added to equals, the wholes are equal. I hope children you are understanding these. Yes, Yukta, Sampath, Rohit. Please unmute and say.
Yes, ma'am. Yes, ma'am.
Purujit, Harshit, Jitendra,
Yeah, ma'am, understood.
Yes, ma'am.
Akshara. Akshara is here. Akshara,
Yes, ma'am.
are you understanding?
Yes, ma'am.
Okay. Where is that girl? One more girl had joined, no? New. What was her name? I forgot the name. Her surname was Gupta. She didn't join today. Okay. Right? So I hope you are understanding the things now. So this was a small calculation, not calculation only, but you just had to make the things equal. Okay. So if equals are added to equals, the wholes are equal. Okay, let's take something more. Okay. Now, would you like to try some question? Shall I give you some question to try?
Yes, ma'am.
Okay, so please write down. The figure also I'll make if OX is equal to half of XY, PX is equal to half of XZ, and OX is equal to PX, then using Euclid's axiom, show that xy is equal to xz. Now I'll make the figure here. The figure is like this: x, y, z, and this is from O to P. O and this is P. And this is the figure. Please try this. It's given OX is half of XY, okay. PX is half of XZ, okay. And OX, O to X, here, OX is equal to PX. Then using the Euclid's axiom, show that XY is equal to XZ. So please try this.
Ma'am, is it when equals are subtracted from equals, the remainders are equals?
Okay. So that you have to prove that XY is equal to XZ. You cannot assume that first. This you have to show it. You are given that this is half of this. You
Ma'am?
have to show that the full lines are equal.
Ma'am, can we use if the equals are half, if the things are half of the same things are equal to one another?
If equal things are half of the same things, what is that? Just
Ma'am,
say clearly.
if
Things
things
which
are
are
equal,
half of the same thing.
that one.
But how do you know that they are same things?
Ma'am,
This
because
you
we can
this
say
you have to prove. This you have to prove, no? ये तो आपने prove करना है ना पहले. कोई और एग्जाम सोचो. Something else that follows.
ma'am, we can show things which are double the same things are equal to one another.
Yes, that can be better. Yes. Things which are double of the same thing are equal to one another. That can be better.
Okay, ma'am.
So Px, Ox is equal to half of xy, Px, we are given it's half of xz. And what else we are given? OX is equal to PX. Okay. So from all these things, what we can find out here, we can even say that if OX, okay, half of XY,
Ma'am, can we write it as OX plus OY is equals to XY?
Ma'am, we can cancel half in the both of them.
see here what I have done here. I have just written whatever was given to me. I've just written it like this, and these three things are given to us. No, this one, and this one, right? So I've just written it. Now I can see this. It's also given the OX is equal to PX. So OX was half XY, PX was half XZ. So I've just equalized them, right? Right? And half can be cancelled from here. So I can see that XY is equal to XZ. ऐसा कह सकते हैं ना?
Yeah, ma'am.
So you can even say that things which are double of the same things are equal to one another. And you can also say that things which are equal to the same thing are equal to one another. Things which are equal to the same things are equal to one another. That also you can say. So both ways you can say. Have you understood this? I'll just write down. Just now, whatever you said, no, somebody said just now, things which are double of the same things. That is also told you. So first thing you can say is that things which are equal to the same thing are equal to one another. Things which are equal to same thing are
Yes,
equal to
ma'am.
one another. We can see this. This is one way of saying the thing. Another way of saying is that things which are double of the same things, which are double. So we could say that these things were double. OX and PX were the double of these things, no? The same things. Things which are double of the same things are equal to one another. Yes?
Yes, ma'am.
I hope you are understanding. Not much of calculation, but only thing is just think of the axiom that applies. Okay? So don't just restrict to one axiom. It can be many. See, as we could say here this in two ways. है ना? हम two ways में इसको कह सकते हैं. So if it is two ways, three ways, whatever, we just have to jot down. Okay? Please note down this. Let's see some more examples. Okay, let's do this one. Have you noted down this? Children, have you noted down? Hello, tell me something. Are you noting down or should I scroll up?
I'm completed, ma'am.
Okay, so now see next question. In the figure, I'll show you the figure also. In the figure, okay, just I'll show you the figure here made. This is like this. Okay, the figure is from A to B. This is A, this is B, and in between there is P. And this figure is D and C, and in between there is Q. Okay. Okay, in the figure, AB is equal to CD. Okay, AB is equal to CD. P and Q are the points. P and Q are the points on AB and CD such that AP is equal to 1/3 of AB. AP is equal to 1/3 of AB and CQ is equal to 1/3 of, this is 1/3 of CD. Okay, show that AP is equal to CQ. You have to show that AP from A to P is equal to CQ. Okay, state which axiom you can use here. Also give two more axioms other than the axiom used in the above situation. Okay, so you have to say which axiom is used here and you have to state two more axioms. Okay, this question is asking for 3 axioms to be used. State which axiom is used here. Also give two more axioms. Also give two more axioms. To support your answer. Okay? To support your answer. To support the situation. Okay. So what, just read the question, understand the question first. In the figure AB and CD, these two lines are given. It is said that P and Q are the points on these two lines. Hello, are you there? Yes. It is given that P and Q are the points on AB and CD such that AP is 1/3 of AB and CQ is 1/3 of CD. Show that AP is equal to CQ. You have to show that this part of the line is equal to this part of the line. Now state which axiom follows and give two more axioms. Okay, just think of it. What will you do? Let's just write down whatever we are given. सबसे पहले क्या करते हैं, जो भी हमें दिया होता है, we should write that AB is equal to CD is given. Okay, AP is equal to 1/3 of AB is given. CQ is equal to 1/3 of CD is given. Okay, and we have to show that AP is given. This is given, and this is to show. Okay. To show that AP is equal to CQ. Okay, so CQ. AP is equal to CQ means AP can be written CQ value is given here. Okay, so in place of CQ, I can write like this 1/3 of CD. I can write, no? Can I write it like this?
Yeah, ma'am.
Okay. What else can I do now? How do I write CD down? 1/3 of C. 1/3. Just a second. See the figure. 1/3 of CD is CQ. 1/3 of CD is CQ. That means in place of 1/3 of CD, I can write CQ here. Yes, I can write this here. In place of this, I can.
Ma'am, I have a doubt.
Yes.
Ma'am, how is it 1/3 of, how is AP 1/3 of AB?
One second. No, it's not A. Just a second. Where is AP first? AP is here. No, why have we written this? AP
Ma'am,
was 1/3 of AB. Okay, AP was 1/3 of AB, And I wrote AP is equal to 1/3 of CD.
Ma'am, how is it 1/3 of AB?
1/3 of AB is already given to us, no? This is given to us.
Ma'am, can you show the figure once again?
Just a second. I'm just trying. I haven't reached the conclusion. Okay, AP is equal to 1/3 of AB. Okay, this is given. CQ is 1/3 of CD. Okay, that is also given. We are given that AB is equal to CD. AB is equal to CD. This is also we are given.
अगर AB को CD
So what? Look here. 1/3 of AB. So in place of AB, if I can write here CD. Okay. Yes, it's going like this. See, this part is given. Look here. This part is given to us. Right? This part is given to us. AP is 1/3 of AB. And we also know that AB is equal to CD. So we can write here AB is equal to CD. Just replacing this AP with CD. And 1/3 of CD is CQ. So that means AP became equal to CQ. Yes, you get it now? Do you get it now?
Yeah, ma'am.
I can this with this thing. This was given. See, look here, children. AP is given here 1/3 of AB. This is given. And if I just replace this AP with CD, why did I replace? Because I'm already given AB is equal to CD. Yes. And now I can write 1/3 of CD can also be written as CQ because this is also given the same way. Yes. And hence we have proved this is what we were asked to prove. This thing AP is equal to CQ. We were asked to prove this only, no? This part. Right? So we have shown what we were asked to find out. Now, which axiom follows here? Which axiom follows here? Equal parts. See, these are equal. See, AB, the two lines were equal, is it? So, equal parts of equal wholes. Yes? Can we say that?
Yeah.
It was that, no, that, what was that? Another thing was there, no, in the, the whole is greater than the part. We can say that? No. One second. Which axiom follows here? We can say the two lines are equal and their equal parts are also equal. This is the axiom. So which axiom follows here? This is what we have done here. The lines were equal and their equal parts were also equal. So which axiom follows here? Just look into the list of axioms. Are you looking into the list? Okay. So please write down. Equal parts. We can write here like this. Equal parts of equal parts of equal wholes. Although it is not there in the list, equal parts of it was in the different one. Equal parts of equal wholes are equal. So the two lines were equal and its equal parts were equal. Equal parts of equal wholes are equal.
Yeah.
We can say something like this. And which other two ways we can say? Any more two ways we can say this? We can also say that whole is greater than its parts. Is it? Wholes are greater than its parts. Are you understanding, children? We just have to find some similarities between these axioms. Okay? Even though they are not exactly same to same, but we have to, closely relate that which axiom closely relates with this situation. Are you getting?
Yes, ma'am.
Yes, ma'am.
So just, try to correlate which axiom or postulate closely relates to the situation. So wholes are greater than parts. Okay, we were talking about wholes and we equated the parts also. Any more thing? We are asked to give 3 axioms. So think of what can we do for the third one. Things which are equal to the same things are equal. So things which are equal to the same thing. So what we were given some equal things were given. Things which are equal to the same things are equal. We can write that. We were given AAB is equal to AP is equal to this, CQ is equal to this. So that means 2 things were equal to this 1/3. Where AD and CD were also equal. So yes, we can do that. So please write down things equal to the same things. Your class time has exceeded, children. Please, this will be the last class. Okay, things equal to the same things are equal. Yes. So you got it, children?
Yes, ma'am.
I hope you have understood. So just try to, find the axiom which closely relates with the question situation. Okay?
Okay, ma'am.
Okay? So please do that. Okay, so please go through it and prepare well for your Sunday test. Okay? Right, we have a class tomorrow also. We'll do some more practice
Yes,
tomorrow.
ma'am.
So thank you for today, children. Bye-bye.
Thank you, ma'am.
Bye, ma'am. Thank you,
Bye,
ma'am.
Beta. Bye.